How'd you guys like the pretest yesterday?
I think I got 2%.
2%? Hey, that's better than 0.
One question right.
Okay. But did the unit look kind of hard?
Yeah.
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 Yeah. You took it, right? Yeah. I'll say that it's a lot of algebra steps. But like once it looks big and like scary, but it simplifies down pretty nice. So it looks bad. It's not terrible. I think you guys got it. I think you'll get it. So we'll talk about simplifying rational expressions first and then go into multiplying and dividing them. So a rational expression is just a polynomial, let's say p, over another polynomial q. They're just being divided. And how often can you divide by 0? Does anyone know? Like, have you ever put like 4 divided by 0 in your calculator? It goes like syntax error, undefined, something like that. You can't do it, right? So q can never be 0. So there's 3 examples of different rational expressions. We have a quadratic over a linear equation. Then we have a linear with 2 different variables over a quadratic with 2 different variables. And then just 2 monomials. So there's just a couple examples of different ways to write them, but there's a lot. So the domain is where like the values of x are on like the graph essentially, but it is undefined when the denominator is equal to 0. So it's usually written as like x cannot equal some number. So if we look at this first example, are there any values of x that will make the denominator 0? No, right? Because 5 will always equal 5. There's no x to plug in a number. So in this case, it is all real numbers. But if we look at this one, there's not just a number in the denominator, right? There's a quadratic. How can we find the zeros of a quadratic? You spent like a full unit doing this. I'll make it easy. All of the quadratics can be factored with magic numbers. 2 and 3. So, but what would the factors be? X. What would the factors be? So then the zeros, or how often can you divide by 0? Never. So that's our denominator factored. So what would my zeros be? Yeah. So x equals -3 and x equals 2. So then x cannot equal -3 or 2. How do we feel about finding the domain? Do you want to try one?
So that's the domain right there, the x does not equal it. That's your answer?
Yeah, so any other value of x could work. Just, it cannot be 3 and it cannot be 2. If you graphed this, there would be like 2 holes. So when you were like approaching -3, it would say then undefined and there'd be like an open hole. And then the same at 2. How do you feel about that? Do you want to try one? Sure? Okay. Let's do... we'll do x. Try that one.
Because it's -8 times 1 is -8, -8 plus 1 is -6.
Yeah, but
So we might just-
it would be those.
It'd be x minus 8, x plus 1.
So then how would that
Oh,
change your
it's
factors?
inverse.
Yeah, there you go. Looks good. Okay, you can erase it. Did you get it? Nice. Pretty easy, right? Yeah. We'll still use this, like factoring and finding the zeros of the denominator. It just gets a little more complicated. Well, there's more steps involved. But we feeling solid about the domain? Okay. So if we get into simplifying it, it's kind of just like normal fractions, right? Whatever you have in top cancels out with the same thing in the bottom, right? So if I had like 2 times 4 on the top and 2 times 3, what would cancel? The 2's. So in this case, if we had those same polynomials, p and q, and r, where r is not 0, it can be split up to p over q times r over r. And what's r over r? 1. So then we're just left with p over q. So a little like checklist that we could talk about to simplify. We want to completely factor the numerator and the denominator. We worked with factoring out the denominator, just we're doing it in both of them now, and then divide out common factors. So a rational expression is a ratio of 2 polynomials, and then again with the checklist, factor everything, and then simplify the monomials if you can, and then eliminate common factors. How could we simplify that one? 20x to the 6th over 14x squared. Five sevenths? 10 sevenths. And then how would we do the variable? Because we subtract exponents, right? Looks good, right? Okay. Okay, if we look at this one, what's your guess that we could pull out of the top? We're trying to eliminate fractions here. That's the whole point. So what could we say is a factor of the top? X plus 2, right? So how would we then find what's left if we divide those two? Not quite. We're going to do division. Which division do you think we could do? Synthetic or long division? Yeah, we could do synthetic. So what would go on the outside? -2. And then we just get 1, 0, 0, 8. We drop the 1, then multiply, add, multiply again, add. And then this would give us -8, right? And then our 0. So this would become the answer, which is what? How could I write that as a polynomial? Yes. And what value of x do I have to exclude? What value cannot be in the denominator? -2, which is the 0. So we factored out the x plus 2 of the top. We get that polynomial. Cancel. We're left with the quadratic And then in the domain, x cannot equal -2. Feeling okay with that one?
In the quadratic, it's just the answer.
Yeah. Yeah, it doesn't want us to solve, it just says simplify.
Oh.
Okay. We'll move on to another simplifying one. So if we look at this like watch out box, we have a minus b over b minus a. How could we rewrite this bottom one to kind of look like the top? We'd have like negative a plus b, right? If we rearranged it. Then if I wanted a positive a and a negative b, what would I take out? Yeah, -1. So then I get -1 times a minus b. So it would be this under that. So what would happen? What would that simplify to? -1. So we can just rearrange them, is what it was going for. So if we look at this top one, or the same one right there, how could we simplify it first? What's our first step usually? So you would rearrange first? We don't necessarily need to do that. What was your first step when you found the domain on the boards? Yep, so in this case, we're gonna factor both the top and the bottom. So if we factor the top, what could we pull out? A 5. In this case, we're gonna pull out a -5 because it'll work out nice with x minus 9 being a factor of the bottom as well. But 5 works, and then if you notice that you have to pull out a -1, you can do that later. How would we factor this bottom part? Magic numbers do work. Multiplies to 27, adds to -28. Okay, if we use grouping then, what would we get if we simplify the bottom? What could we pull out here? An x. Okay, so then we're just left with 3x minus 1. What about over here? Pause the -9, yeah. Okay. And then rewrite it. And that's why he pulled out a -5 instead of a +5, because we also have a factor of x minus 9 in the denominator. And it's always nice to just keep a list of the values of x that don't work, because when we get into dividing ones, we'll have to add other zeros. Okay, so what would this simplify down to? -5 over 3x minus 1. And then this just was talking about pulling out a -1, and you can rearrange. How are we feeling about simplifying it? Okay, we'll try this one on the boards to simplify. Okay, what was your first step? Factor. So what would you factor out of the top? 3a. Then we're left with 4a squared minus 1. What about the bottom? What did you factor out? 6a squared. And then I'm left with 2a plus 1. Okay, what do you think about here? Yep, what would it factor into? What could we do? Yeah, so difference of squares. 2a plus 1, and then 2a minus 1. And then the bottom just stays the same. Okay, what do you notice here? Cancel the factors. Can we cancel out anything else? Yeah, how could we simplify this? Yep, 1 over 2a, because this becomes a 1. This becomes a 2. Cancels that with the squared. So then we're left with 2a minus 1 all over 2a. So that's the simplest form we can get it in. So at that point, we'd be done. We just have to list what values of x have to be excluded. What would those be? 0 is one of them. What's the other one? -1/2 from this stage. Feeling good about that?
0 is always just a given.
Not always. In this case, because we had that 6a squared as a factor. But if we had two, like if we think about the one you guys did on the board, factoring it to find the domain, 0 wasn't in that one, right? It was 8 and -1. So it just depends on what factors you have in your.
So if it's just like an 8 on the outside of the board.
If you have a variable kind of by itself, then you'll get a 0. Okay, we're going to talk about multiplying now. So there's a little process. If you have monomials, you can just multiply and then simplify. If you have binomials or trinomials, you'll factor and then simplify. Does that make some sense? Okay, so if we factor this example, what would my numerator become? What would we factor out? 4x. So then we'd get x minus 1. What about our denominator? What can we factor out? A 2. So then we're left with 2 times the quantity x squared plus 2x minus 3. What would we do with the top? Magic numbers? What would my magic numbers be? What about the bottom? What could I pull out of the bottom? 4x. So then we're left with x plus 2. Okay, can we factor the denominator a little bit more on that first fraction? Yeah. So if we factor this portion, what would we get? Yep, x plus 3, x minus 1. So if we stop at this stage, what values can x not be equal to? So we have 1, -3, 0, -2. Okay. So, which is this step, and he is combining them into one big fraction. If you wanted to, you could simplify here. Like we could notice there's an x plus 3 and an x plus 3. But if we get into simplifying, what would cancel? Yep, so we got x plus 3, x minus 1. What about the 4x over 4x? Would those cancel? Yeah. So then we're just left with x minus 2 over 2 times x plus 2. How do we feel about that? Okay. So if we work on dividing, do you remember how you divided like a fraction over a fraction? What's the strategy for that? Someone mentioned last period, keep it, change it, flip it. Does that ring a bell? So then you multiply by the reciprocal of the denominator. Ringing bell a little more? No? Okay. We'll do, if we looked at like 1/2 divided by 3/4, we want to multiply by the reciprocal of the denominator, which is just it flipped. So we would do 1/2 times 4/3. A little better? Okay. So if we divide this, our first step is always going to be to factor everything first. It just helps us to see like what we can simplify towards the end and our zeros that we need to exclude. So if we factor this top equation, what would we pull out? Okay, 2x squared. So then we're left with x minus 6. And then we can use magic numbers to factor the bottom. So get x minus 6 times x plus 2. If we factor that second fraction, what do we get? I'll say he pulls out a negative. We pull out a negative. So we'd pull out a negative 8x squared. So we get x minus 3. And then magic numbers on the bottom. So then the x's cannot be 6, negative 2, 5, and 3. Okay, what do we do at this stage? We've factored, so we have to flip it. So we're just rewriting this. This one just drops down, this one flips, and it changes to multiplication. What new 0 do I have then? 0, yep. So with dividing, we have to look at what values have to be excluded before we flip and then after we flip. Okay. If I multiply those, what am I going to get in my numerator? What are all the factors? It's just going to be everything, right? And then all of the denominator. Okay, what can you see simplifies? Okay, so these ones. What can we do with this? So we take out a 2x squared, and then we're left with what in the bottom? Okay. So that would look like this, right? What if we wanted the negative out of the denominator? What would we do? Yeah, multiply by -1. So we'd get 4x squared, or 4x plus 2. And then what would happen with the top? Yeah, so they'd flip. And we would get, flip it here. 5 minus x over 4 times x plus 2. Feeling okay with that? Because the next one you have to try. So any questions? Okay. Okay, have fun with this one.
Well then.
Try to write small. Quick. And then that'll probably be the end of class. So what was your first step? You factored them out. What did you get for the factors of your first fraction? Okay. And what about the denominator of that one?
Just see.
Okay. I like it. What about the second one? And then the bottom? Okay. Did you keep the division and factor the bottom, or did you flip it and factor? You flipped it? Did you factor at the same time? Okay. If we factored, or if we flip and factor, what would the numerator be? We factor. Okay. And then what's our bottom? So what zeros can I not have? -7, 6, -1, 4, 3. We would have to check these ones too, right? Because we flipped them, but we already got those with those ones. Okay, what cancels? So we got x minus 4, x plus 3, x plus 7. So what am I left with? And then we had that list that it cannot be. And we wouldn't need to FOIL it all out. We can stop here. Feeling solid? See, it looks bad, but it simplifies down pretty nice, doesn't it? Okay. That's all I got. Got 4 minutes. Just relax.